I notice I've left something off over here, and that was one of our directions on the first page to make sure that we put the mass of the hangar in the data table here under number 5. So come back to that, and we want to make sure the mass of the hangar is here, and it needs to be in kilograms. Well, we don't need to put this back on the scale again because right here it says 5 grams on the side, and it might be kind of hard to see on the video, but you can see it in real life pretty easily. So it's 5 grams. So we know that that is going to be 5 grams. And we're going to use our conversion here. So I know that 5 grams is going to be equal to 0.005 kilograms. I've got to move that decimal place 3 times to the left. And here it is. So I'm going to move it out 1, 2, 3 times to the left. So I know that is 0.005 kilograms. So I would record that here. And that's what we're going to use for this one. Now, we need to next fill out the mean acceleration of this. So your mean acceleration we can find from this third graph here. And it says on the second page of your lab under letter B, use the start and end markings on figure 3, start and end. Okay, so we're going to find that start and end here, and we're going to make a box around the start and end by clicking on that start somewhere right about here, holding it, dragging it. So I clicked and held and dragged, and I'm going to do that all the way to the end, right about there. Okay, and then coming and clicking on the statistics button. So up here it's the 1 with the curve 2, and down here it's going to give us the mean for it. So here is our mean acceleration. It is 0.06354. And that would be in meters per second squared. So make sure that I put that unit there. Alright. So then we just need to do this 3 more times. We've got 3 more trials that we have to do, so we just would reset this back to, and I started at 35. So reset this back to my start. And I just remembered that. You might write it down initially so you don't forget where your start is. So we would do that again, put that at 35, come back to Logger Pro, and click collect. Okay, and let that collect data again. Okay, try and stop that at the end so it doesn't bounce too much. And then you'd basically be doing the same thing. We want to find our initial velocity, our final velocity the same way, as well as our mean acceleration. We would do that another time, and then we'd come up with our averages. You'd have to go get a calculator and average out these 3 columns. Now, to find the force, what you need to do is take the mass here and multiply it by the acceleration due to gravity, which we've been using 10 a lot, but when we're doing real life stuff, we need to use 9.8 meters per second squared. That's that. So we're going to take the mass here, multiply it by 9.8 meters per second squared, and we will get the force here. And of course, it will be constant the whole time because we didn't change the mass of the hangar during this. Okay? Then we would come through, and it says that we're basically repeating steps 7 through 8 2 more times, filling out that data table. Then in step 10, we're going to remove a mass from the cart and transfer it to the hangar. So we're going to do this. Remove a mass from the cart and transfer it to the hangar. Okay. So notice that the mass of the system, the cart, string, hangar system stays constant. We don't change the mass of this system. The system stays constant in terms of its mass. But we know that's going to pull harder on this cart and hopefully cause it to do something. And that's the point of this lab, is to figure out what it's doing to that cart. So then you come back and you want to click collect, and then you're filling in this next data table. Then we would transfer another mass to that hangar, do it 3 times, fill out the data tables, transfer the last mass to the hangar, fill out this last data table with 3 trials. Each time averaging the initial velocity, final velocity, and the mean acceleration. All right, and that basically walks us through a lot of this lab. We've gone through our data tables here. Then we're going to have to plot a graph of the force versus the average acceleration, find a regression equation for this, and so we could replot that into a new logger profile. And for your regression equation, remember we're always going to get that in terms of y equals mx plus b. And on logger pro, this is given to you as your slope, and your b is your y intercept. There. Okay, so you're going to make sure to get that regression equation, find the slope of the line that's created here, and then you'd have your y-intercept. Now, if we look back through here, it just says, again, how basically to do your lab write-up, how to make sure to do your diagram in your lab. It talks about error analysis, include error analysis section, compare the slope of the graph with the total mass of the system. So we want to compare the slope of this line back to the total mass of our system here. And hopefully you'll see that they are the same. They should be the same. If they are not the same, then we need to explain what factors could have prevented our data from making a line whose slope is the total mass of the system, why this and the slope of this line are not the same. You'd have to do that under error analysis. Then in your conclusion section, state Newton's second law, and you can look that up on the internet, explain how the equation for Newton's second law was derived from the force versus acceleration graph. Then explain what the y-intercept of the above graph, if any, represents. So what